Good morning, children. Welcome to our chemistry online class. Last class, we have discussed about very important gas laws such as Charles' law and Gay-Lussac's law. So, in today's class, we are going to discuss about another gas laws. And this gas law is very important. This is Avogadros law. What do you mean by Avogadros law? Avogadro law states that volume is proportional to the number of moles of gas. In the time, the pressure and temperature will be in constant. Equal volume at the same temperature and pressure contain equal number of moles of gas. That is, if you take a certain volume of gas, it contains certain amount of moles. If we take same volume of different gases, all gases having same number of moles. This law can be represented by V proportional to N. We know we have to change this proportionality constant. This proportionality, so for that we have to multiply it with a constant, that is we can change it as V is equal to Kn. The K is a proportionality constant here. So, for example, if we take different gases, hydrogen, nitrogen and oxygen. If you see this, you can see this all gases having same volume. So, if they have same volume, the number of moles in hydrogen, nitrogen, oxygen will be same. This is Avogadros law. This law is proposed by the scientist. He is very famous. His name is Avogadro. So, as per Avogadro's law, V proportional to N. So, V is equal to constant into N. So, we can write it as V1 by N1 is equal to V2 by N2. Based or using this equation, we can calculate V1, N1, V2, N2. Such as in Boyle's law and Charles' law, we have seen such problems. This is the graphical representation of Avogadro's law. Here, volume is in x-axis, number of moles, that is N in y-axis. And volume increases, number of moles also increases. Here, pressure and temperature are held constant. And one more important thing is there in Avogadro's law, that is STP. STP means standard temperature and pressure. What is a standard temperature and pressure? As per experiment, it is identified that standard pressure means 1 atmospheric pressure. That is, in short form we will write 1 atm. And what is standard temperature? That is 0 degree centigrade, that is 273 Kelvin. So, any gas at 1 atmosphere and 273 Kelvin having 22.4 liter of volume. If you take any gas in 1 atmosphere and 273 Kelvin, it should contain 22.4 liter. So, from experiments, it is identified that any gases at 1 atmospheric pressure and 273 Kelvin temperature contains 22.4 liter volume, 22.4 liter gas. So, 1 mole of any gas is equal to 22.41 liter at STP. Children, you have to keep it in mind. So, this is in the case of 1 mole. So, 1 mole we know that is molar volume. We can call 1 mole as molar volume. So it is volume of gas occupied by 1 mole of a gas at STP. So how many moles are there in what is the number of atoms in 1 mole? Do you know? In small classes you have studied this. In 9th standard you have studied this. That is 6.023 into 10 raised to 23. If you take 1 mole of any substance, it contains 6.023 into 10 raised to 23 moles. So 22.4 liter volume contains 6.023 into 10 raised to 23 number of moles of gas. So number of atoms of a gas. So this number is known as Avogadro number. In your previous classes you have studied this. So you have to keep this in mind. Then we'll move to ideal gas equation. What do you mean by ideal gas equation? We know so many equations. We have studied so far so many laws. That is Avogadro law, Boyle's law, Charles law, etc. So in each cases if you take, for Boyle's law, we know volume is inversely proportional to the pressure. That is, if volume increases, pressure decreases. Here, what all these things are constant? Number of moles and temperature. In Boyle's law, at constant temperature, volume of a gas is inversely proportional to the temperature. So, here number of moles and temperature are constant. If we move to Charles' law, according to Charles' law, we know that volume is directly proportional to temperature at constant pressure. So, number of moles and pressure are constant here. If we take Avogadros law, what are the variables are held constant? Pressure and temperature. And volume is directly proportional to number of moles. So, if we take or if we check the left hand side of these equations, V proportional to 1 by P, V proportional to T, V proportional to N. So, the common factor V is common for all these things. So, generally we can write it as V proportional to, what are the constants are here? P, it is 1 by P, so P will be in under. So, NT. So, the equation will be V proportional to NT by P. If we combine all these equations, we will get a new equation V proportional to NT by P. So, if we change the proportionality sign, we will get a constant, that is R. V is equal to nRT by P. This R is the gas constant. And if we rearrange the equation, if we P moves here, we will get PV is equal to nRT. This is the ideal gas equation. In this equation, we know pressure is there, volume is there, number of moles is there, temperature is there, gas constant is there. So, all variables such as pressure, temperature, number of moles, volume, all are including in this. So, this equation also known as combined gas equation or universal gas equation, etc. And this R is the gas constant having a certain value. According to the pressure and temperature are given, based on that the R value will be changed. If the pressure is given in the atmospheric pressure ATM, that is 1 atm, 2 atm, etc. and the volume is given liter, the number of moles in mole and temperature in Kelvin, this will be the gas value. If pressure is in joule and temperature in Kelvin, this will be the value. If pressure in the kilogram meter per meter square, temperature in Kelvin, this will be the value. So, you can use the Clerk's table to identify the value. So, there are so many values. Then this gas constant is known as universal gas constant. Then we'll move to Dalton's law of partial pressure. In this you can see three containers. Container A having a gas A, B having gas B, and container C having both A and B are there. So in the container A there will be the pressure of gas P1. In container B it will exert a pressure P2. What will be the pressure in the container C? It will be the total of the gas A and gas B. This is the Dalton's law of partial pressure. This pressure is known as partial pressure. Each gas exerting some pressure. So this pressure is known as partial pressure. So the total pressure in a container will be the sum of the partial pressure of each gas. So the total pressure in a mixture of gases is the sum of the partial pressure of each gas. So if we take a mixture of gases, there will be, if we take air, in air oxygen is there, chlorine is there, carbon dioxide will be there, nitrogen will be there. So all having its own pressure. Its own pressure in the total pressure. So such pressure we can call it as partial pressure. So if you want to calculate, we can use the equation of ideal gas equation. That is PV is equal to nRT. So if you want to calculate the pressure of A, so we can give, instead of P, we can write PA. So PV is equal to nRT. What will be P? P will be nRT by V. So we can write PV as P as nRT by V. So PA is nRT by V. So instead of N we have to write Na. That is number of moles of A. There will be number of moles of all gases. So we have to consider only number of moles of A. So PA is equal to Na RT by V. Similarly PB is equal to NB RT by V. PC is equal to NC RT by V. So we know Na, Nb, Nc are number of moles of gases A, B, C respectively. So we know total pressure is Pa plus Pb plus Pc. So if we substitute the values, we'll get like this. So here if we check, this RT by V is common. So take this outside. So what are there will be inside? Na plus Nb plus Nc. So if we take the equation, so PA, if you want to calculate only PA by P is equal to, so if we take PA to this side, what will be there? Na by RT by V. So if we take PA, we want to calculate PA by P, and we know PA is Na by RT by V. P is equal to total. So P is equal to, from the equation 1 we can see that P is equal to RT by V into Na plus Nb plus Nc. So Pa by P is equal to, here also RT by V, here also RT by V. So we can cancel this. So we'll get Na by, what is left over there? Na by Na plus Nb plus Nc. What is this Na plus Nb plus Nc? It is the total number of moles. So this is the number of moles. So number of moles divided by total number of moles. This value is known as mole fraction. So Pa by P is equal to, this mole fraction can be denoted by the letter chi. So where chi A is this mole fraction of A is equal to Na by Na plus Nb plus Nc. Similarly, so Pa by P is equal to chi A. So P is equal to chi A into P. P is equal to, we'll get such equations. Thus, partial pressure is equal to mole fraction into total pressure. Such types of problems also you can expect. So, we'll solve problems in next class. Thank you.